Okay, next we are going to do integration by partial fraction. I hope you still remember what we mean by partial fraction. This one we learned in semester 1, isn't it? Okay, now look at this. After I will go through quickly what is partial fraction. Okay, look at this. Let's say I want to integrate this. This one actually is a proper fraction. Why? Because here the power is x power 0. And then this one x power 2. So very good. It's a proper fraction. Okay? And then you see, when I want to integrate this, I just write this one, x squared minus 16 negative 1. So the bracket is here, negative 1. So when I integrate the negative 1, what will I get? I will get ln, isn't it? That modulus x squared minus 16 plus c. But this is not yet completed. What we must have here is what? Don't forget this step. Okay, this one of course ln is correct. Negative 1 become ln. But you still miss one step here. What is the step here? You must have 2x. Because you differentiate this, you have 2x. That means you have to add 2x. Here you have to divide by 1 over 2x. So the answer is 1 over 2x, isn't it? So if it is the case like this, this is wrong. Why? Because whatever we add here or whatever we divide here is only numbers. You cannot have x. If you have x like this, it's wrong. Okay or not? What I mean, let's say you have this, you want to integrate this. Let's say I give you, this is x squared minus 16 dx. Let's say you want to integrate this. This one can be written as x and then x squared minus 16 negative 1 dx. Correct? I write it here because no space. So here you see, this negative 1, when I integrate, I will get ln. It's definitely correct. X squared minus 16, then plus c is definitely correct. Negative 1 integrate, change the function, become ln. But one more step. Here, when you differentiate, is it you get 2x? But the x is already here. So you just add a 2, you divide by 2. So you get 1 over 2. This one is 100% correct. Because you add only numbers. But here, no. The x is not there. So you have to add the 2x, you have to divide by 2x. That's why this is wrong, because you involve the x. Okay, yeah? So this method is already failed. That's why we are going to other methods. So if you have case like this, that means you cannot do like this. Unless you have the x here. So you have just add the 2. Okay, so in this case, how to do? So what we do here, every time you see, if this is a proper fraction, you see whether the denominator can be factorized or not. This case can be factorized. So can be factorized, then we can use partial fraction. 1 over x plus 4, this one, a, remember this. And then how to find the a and b, like that. Okay, then you substitute x equal to 4, x equal to negative 4. Then you get your p is 1 over 8, your a is negative 1 over 8. So of course, we write the positive one first and followed by the negative 1 over 8. So that means you get this one 1 over 8, b, x minus 4, and this one. Okay, then after it, now you see, I'm going to integrate this. This is the same one. So 1 over 8, I take out, x minus 4, negative 1, negative 1 over 8. Then this also x plus 4, negative 1. And then you see, now I'm going to integrate this. I'm going to integrate the negative 1. So when I integrate the negative 1, I do ln. Then modulus x minus 4 ln x plus 4. But there's one more step to do. Don't forget this. When you differentiate this, you have 1. So if 1, this is 1 over 1. That means you don't add anything, isn't it? So this one also 1. That means 1 over 1. That means you don't add anything. Therefore, you still have this. And then because of ln, you can use the logarithmic rules. Then 1 over 8 you take out, then minus become divide. So this is the answer. Okay, and then you look at another one. Okay, let's say you look at this one. This one also proper fraction. Why? Because this is 1 and this is 2. And then you see, when I want to try to integrate this one using the first method we learned, I try to change this one into ln. I change this one into ln like that. But this one whether correct or not, you see, when I differentiate this, what do I get? I will get 12x plus 11. But this one, is it 12x plus 11? No. Therefore, this is wrong. Okay, so wrong, salah. Therefore, we have to use partial fraction like this. We factorize, this one can be factorized. Then you change it to a and b. Then we try to find a and b, 8x minus 2. Then this one, a times this one, b times this one you know, you learn in semester 1. Then after that you put x equal to 0, x equal to 1, then you get a simultaneous equation. A is negative 2, then your b is 4. Therefore, a is negative 2. We write the p4 first, followed by the negative 2, and then now we can integrate. So here you see 4 you take out, and then 2x plus 3 negative 1. This one 2 take out, 3x plus 1 negative 1. Okay, now I'm going to integrate this. Integrate this will give you ln, isn't it? Will give us ln. But before that, here you must have 2, isn't it? Differentiate this, you have 2, so divide by 2. So differentiate this, you have 3, so divided by 3. So with this one can become ln. That's why this is 2, this is 2 over 3. Okay, and then what is the meaning of this? The limits here, you substitute 1. So when I substitute 1, I get 2 times 1 plus 3 is 5. Then when you substitute 1, you minus ln 3, because this is 0, is ln 3. Then minus 2 over 3, ln this one is 4 minus this one, and this is 0. So therefore you get this. Okay? Okay, next one, last one. Okay, when you come to this, let's say you have this. Okay, this one also improper fraction, because why? This is square, this also square. So this one is square, this one also square. See, actually this one should be smaller, the power or the degree. So what we have to do, you have to divide. So divide like that. Okay, 6x 0, then you divide, then finally you have this. Now this one already become proper fraction. So this one become proper fraction. This one can be factorized, so you use partial fraction. Whenever you remember, whenever this one can be factorized, you use partial fraction. Easier. Okay, so partial fraction, you try to find what is your a and b. I substitute x equal to 0 and so on. Then I will get this. Okay, now so this one 3 I take out, I integrate 1. Here 1 I take out, I integrate 2x minus 1. Here I integrate 4x plus 1. So now I'm going to integrate this one, the negative 1, which will become ln, and this one also become ln, and this one will become x. But here I must have a 2 here, and then divide by 2, isn't it? This is okay because this is a number. And then here, about this part, I must have a 4 here, so I have to divide by 4. Because I differentiate this, I get 4. Okay, then here I integrate the x, 1 I get x, 2, 1. Then this one I get half, this one negative 1 become ln 2x minus 1, 2, 1 minus this one also half, then ln 4x plus 1, 2, 1. And then after that I just substitute 2 and then 1. Here also I substitute 2, 4 minus 1 is 3, then 2 minus 1 is 1. Here I substitute is 8, then minus, I substitute 4 is 5. And then you simplify here, then I take out the half, factorize the half, then this is what I get. Okay, I get 15 over 9 or 5 over 3. So okay, you can try the question given. Okay, so you can try all the question until page 2. Okay, all the question in page 2.